Alright, so today we're going to start our geometry unit. So there's a couple of things. I'm definitely going to want you to be able to use a protractor to measure angles. So I want you to look at your handouts first thing today. So I want to look at kind of some of these. Now notice, if you know something about angles, and we'll write down definitions, if on this matching worksheet that I gave you, it's pretty clear, right, that this is B, right, because it's a right angle, okay? And then you could even reason it out if you wanted to. You could notice that, hey, this is more than 90, and so is this one. And notice whichever one is the wider one, you could probably figure that out. But I want to make sure that you actually know how to measure angles. And so this is what a protractor is, okay? You probably are going to need to get one of your own. They're only a couple dollars at Walmart. You can find them anywhere. You don't have to have one that's this big. Okay, but you'll definitely want it to have kind of where I'm pointing right here, there's kind of a hole, and then it should have angle measurements here. Okay, so let's see if we can actually kind of measure out what this one is. Now, how you measure these, so you need to kind of watch how I do it, is wherever the vertex of your point is, so I'm going to kind of clearly mark that here. Notice that should show up in my, in the hole that I have here. Okay, so right under the letter T, there's a hole in my protractor. Okay, now notice wherever this hits, that's how much it was going to be, but it's very difficult for me to kind of read that. So it's helpful a lot of times if you'll extend out your line a little bit further. Okay, and then we're going to line this up. Okay, make sure everything's kind of lined up. Okay, so notice that it's hard to see, but notice there's two sets of numbers, right? Well, we're starting here and we're reading this way. Okay, so if you start here, and my line was just a little bit off, but notice that we end up right here, which is about at 120 degrees. Okay, so this was D, this was about 120, and then so by default we know that this one is E, right? And then here, I think it's pretty clear, we have two acute angles, right? This one is much narrower than this one, right? But let's just, for maybe one of them, let's just go ahead and label it, or measure it, I mean. So again, it's going to be important that you extend these lines so that you can read it properly. So again, I'm going to mark the vertex pretty exactly. And then you want to make sure you line it up. Okay, notice now this time I'm going this way and reading as I go. Okay, so in other words, I start here and I read this way. Okay, so if I line that back up, then I will get right at 60 degrees. Okay, notice I'm reading right here, right? So this is definitely a 60-degree angle. Of course, we already kind of, actually it's supposed to be 65, so let's go back. I quickly read that, but let's go back and make sure everything is lined up because I was a little off on my measurements. So I have a really old protractor here, so I'm trying to make sure that my dot is perfectly square. Okay, and now I think we're good to go. Okay, so it does read 65, so sorry about that. All right, so process of elimination really gets you the answers here, but I don't want you to base your knowledge of measuring angles just on that. Okay, so on the first worksheet, it should be B, D, A, E, C. Okay, but I want you to take out this second, it's actually 2 pages, and we're just going to do a scattered few of these. So I want you to try to measure some of these using your protractor. So maybe pause the video. I want you to try to measure, let's do angles 2, 4, and 6. Okay, so try to measure angles 2, 4, and 6 and see what you can get. All right, so let's look at 2 first. Okay, now 2 certainly looks like it's a right angle, so I would just suggest though that you actually check it, because you know it could look like a right angle and still be not quite 90 degrees. Okay, so first we want to continue that bar up. So if we center that hole exactly at the vertex, notice it is pointing exactly at the 90, so I think we're 90 degrees. Okay, so some new notation that I want you to know, but this is how you actually write this. The measure of angle AOB is 90 degrees. Okay, so let's go ahead and label that. So this means you actually read this as the measure of angle AOB. Just so you know, we also could have read this angle as BOA, but we would not read it as OBA. Okay, the order of the letters matters, so the vertex or the middle point needs to actually be listed in the middle. Okay, so that one looks like 90. Okay, let's look at number 4. Now, you're definitely on one side going to need to extend the line out, just so that you can read it properly. So if you line up, again, I like to mark my vertex just so I clearly kind of know what to line that up with. Okay, and notice I want to read the numbers that are starting at 0 and counting this way. So if I do that, I've got about 20 degrees. Okay, so for number 4, I'm going to call it BOA this time, just to remind you that we can go this way, right? But the measure of angle BOA is 20 degrees. And then lastly, let's look at number 6. And then you could practice all of them. I'll write down what angle measures you should get. So if you get a protractor and you want to practice a few of them, I think that'd be a really good idea in preparation for homework and for upcoming tests and all of that. So let's see if we can measure this one. And then maybe you can do the rest on your own, and I'll kind of write what measurement I get. So this one is being a little difficult to line up. So this one's going to be just kind of close. Okay, so if I measure that out, notice that it hits really close. I mean, mine is really kind of being difficult, but it's supposed to be 80 degrees. So the measure of angle AOB is 80. Okay, so if you want to, you can check all of these. So let me just kind of run through and tell you what they all are. This one should be 62 degrees. This one comes out to be about 119. We already did that one together. This one comes out to be about 160. Okay, so on that first page, it's 62, 90, 119, 20, and 160. On the second page of this same one, this would be about 80. I already have that one. This one comes out to be about 98 degrees, you know, like the boy band. 42 degrees, 150 degrees, and then 170 degrees. Okay. So go ahead and check those, and just so you know, like, a good rule of thumb is if I gave you a problem like this on a test and I asked you to be able to measure the angle effectively, if you were within like 1 degree of what I said, then I'll usually go ahead and count that, right? Because, you know, there can be kind of differences in how you slide your protractor, but shouldn't be more than 1 degree off. So if you're consistently getting measurements that are off, you might want to, you know, Google search some ways for practicing using a protractor. There's all kinds of resources out there online, but I definitely expect that you can know a protractor, or know how to use a protractor, I should say. Okay, so we're going to be talking a lot about angles today, so I wanted to start with that so that we were on the same page with how to actually measure angles. So let's talk a little bit more about some things we know about angle measures, or things I want you to know. Okay, so the first thing is I want you to know that the angle measure of a circle is 360. Okay, so what I mean by that is if you have like an axis like this and you make a complete circle, then that is 360 degrees. Okay, the arrow is significant because we started here and we went all the way around. Okay, the angle measure represented where the base is a straight line is going to be 180 degrees. So let's say that you had this line Okay, then the measurement from here to here is 180 degrees. Okay, but also the measurement from here to here is 180 degrees. So that's how we get a total of 360 degrees all around. Alright, so I think most of these things were on your glossary. I don't remember if right angle was on your glossary, but certainly a right triangle was. But a right angle, of course, is a 90-degree angle. When we want to show something's a 90-degree angle, for sure, we use this little notation. Okay, use a little box, and that just tells you, hey, that's a 90-degree angle regardless of whether for sure it looks like one or not. An acute angle is an angle that's less than 90 degrees. And then, of course, an obtuse angle is an angle greater than 90. So more specifically, it's an angle that is more than 90 but less than 180. So that's kind of a side note. We don't really talk about that all that much until we get to a little more upper level geometry. But all right, something else on your glossary was the definition of polygon. Okay, so I had you do the glossary so that you'd have some reference for what we're learning now. I don't want you to just memorize a bunch of definitions. I hoped that by you working with them, you would kind of commit some of those to memory. So we're not going to go over all the things on the glossary, but certainly the ones that I go over are ones that I want you to know the definitions for them. So a polygon is just a many-sided shape with 3 or more sides. Okay, poly just means many. Okay, and the reason it has to have 3 sides, just so you know, is you can't make an enclosed shape with only 2 sides. You can make an angle, but you can't make an enclosed shape. All right, so clearly we know what triangles are, right? A triangle is probably one of the first shapes that you'll teach your students when, you know, along with more things like squares, rectangles, circles, but triangles will definitely be in the mix. So a triangle is a polygon with 3 sides. So we're going to use this fact a lot, but the angle measure of all 3 angles inside any triangle at all always adds up to 180. So I think we've known this fact for a long time, right? But the question is, why does this work? Okay, and we can actually use something to demonstrate that. So if you have like any Kleenex boxes at home, you could maybe get something out, or if you happen to have tissue paper like you have that for wrapping presents, I'm going to use something that's really kind of made like tissue paper. It's called patty paper because it's literally like what they put between hamburger patties when you buy them frozen so that they don't stick together. And so what I want you to do on your tissue paper / Kleenex, just honestly, the reason I'm saying it needs to be tissue paper or Kleenex is so that you can kind of see through it. That's going to be kind of important. And what I want you to do is I want you to draw a triangle. It does not have to be any specific type of triangle. So this activity works with any type of triangle. Now I kind of drew a triangle that looks almost like a right triangle. Okay, I could use my protractor to see if it truly was a right triangle. But I want you to label the angles A, B, and C. Okay, and then what I want you to do, you can use your ruler if you want, if you have one, or you can just kind of rip them. I want you to rip the paper up so that we have 3 pieces, and I want like each of the corners to be on one piece. So see how this only has that corner? I'm using my ruler just because it makes the ripping really, really easy. This patty paper is really great for your classroom because it allows you to kind of overlay things. That's what we're going to use it for. Notice how see-through it is, like you can still see my writing. Okay, so you've got the 3 pieces. And then what I want you to notice is if you line them up, in other words, if you notice it's kind of backwards, right? But I have my A, my B. If you lay them right on top of each other where the lines that are forming them are right on top of each other, okay? Notice that I have a straight line under, okay? So, and notice I already know the line measurement, right? What's the angle measurement of a line? It's 180. So I have angle A here. I know it's a little hard to see. Angle B is all the way at the back, so it's really light. And this is angle C. And notice they're forming a line here, okay? Okay, so I'm going to do kind of a drawn version, but hopefully you kind of demonstrated that. But if not, you can kind of write it down here. Okay, so we tore up the 3 angle pieces. So I'm going to show this kind of so that if you didn't have supplies on hand, you can still remind yourselves what we did here. Okay, so we kind of split up the triangle in this way, and then what did we do with them? We lined up all 3 angles by each vertex. And we'll notice that a line forms on the bottom. So in the end, we end up with, I'm trying to kind of show that we still have our torn pieces here, although my pieces looked a little bit nicer, right? Since I used a ruler. Okay, so notice that the 3 angles add up to 180. So this patty paper is really great. Okay, again, here's what it looks like. It's really cheap. You can buy like a box of 1,000 for super cheap prices from like restaurant distributors and stuff. So I use it a lot for when I want to overlay something, when I want to be able to see what's under it but still make a drawing. I've even seen teachers like do like small snacks on them just because they're cheaper than paper plates and also more environmentally friendly, honestly. Just so you know, this works for any type of triangle. I showed what looked like a right triangle, sort of, but it works for an obtuse triangle, it works for an acute triangle. So if you're a more hands-on learner, I hope that you'll try that process on your own, okay, and actually see if you can figure it out, because it's interesting. It's something fun you can do with your students, okay, where you don't have to teach them that, hey, the 3 angles of a triangle add up to 180, but you can actually show them why it's true. Okay, it's always best if we can show students why something is true. Okay, so let's talk a little bit more about triangles and their specific components. So we have different types of angles in a triangle. Most often we're referring to what we call the interior angles of a triangle, and not surprisingly, these are the 3 inside angles. That's what we just drew, right? Our A, B, and our C for our patty paper demonstration. These add up to 180. But probably less talked about, but we can also talk about, less talked about than interior angles is exterior angles. So exterior angles of a triangle are the outside angles. But the only way you're going to really see these is to extend the lines of your triangle out a little bit. So I'm going to say they're formed by extending the sides of a triangle. And there's different ways to extend these, so I want to be clear that the angles that I'm about to show you are not the only ones. So I want you to draw a triangle and mark it ABC. Okay, so if you extended out any side, so if you extended this side out, and then let's say you extended this side out, and then let's say you extended this side out, and we're going to label these angles D, E, and F. So in the pictures, we use this little symbol to symbolize angle, but angle A, angle B, and angle C, sorry I shouldn't have that there, are interior angles. Whereas angle D, angle E, and angle F are exterior angles. Okay, just so you know, we also could have extended this line out this way. Okay, so if we would have extended the line out, sorry about that, if we would have extended the line out this way, then we could have called this like angle G or something. So there is definitely more than just a set of 3 exterior angles. We can actually draw them in many, many different ways. All right, so let's do an example where I ask you to find the missing angles. So I want you to draw a triangle where we already have an exterior angle being kind of shown. And we're going to label this A, B, and C on the outside. And then we'll label this angle D. Or sorry, point D. And let's say that these measurements were given. This is 50 degrees and this is 60 degrees. And so I want us to try to fill in the other measurements, and then we're going to talk about something that we can maybe say. Okay. So first thing is, if we're trying to show why we know what we know that the interior angles of any triangle add up to 180. Okay, so let's talk about how I could figure out this angle that I'm pointing at. So that would be angle BCA, or we could call it angle ACB. Okay, and one of those two would have to be what we would call it. So we have 50 plus 60, right? We have 110 degrees already accounted for. Okay, so then how can we figure out what this angle is? We could subtract it from 180. So we'll do 180 minus 110, right? And that equals 70. So we know that this is going to be 70. So now couldn't we also say what this angle is going to be on the outside? Okay, the exterior angle. So here's our work for that, right? We know that from here to here it's 180 degrees. Okay, so to find the exterior angle, we know that the exterior angle forms a line, right? So the exterior angle is going to be 180 minus 70, which is 110. Okay, and our rule, if we were trying to justify ourselves, is that 2 angles that form a straight line add up to 180. So I'm going to go ahead and measure this, or write this in. So this is 110. Okay. Notice it's important for me with this red to actually say from here to here is 180, so that it's not overly confusing that I'm talking about this angle or something. I'm talking about all the way around. And so if you notice, this 110 is always going to equal these two. Okay. In other words, 50 plus 60 is 110, and so is the exterior angle. Okay, so here's the official rule, and we're going to do some example problems looking at that. So the measure of any exterior angle will always equal the sum of the 2 angles not next to it. Okay, and the word we use for not next to would be non-adjacent. So think about that. If someone lives adjacent to you, they live next door, right? So if you're non-adjacent, that means not next to. But you're going to see that adjacent terminology, so you definitely need to know that. All right, so let's look at a couple, and then we're going to look at maybe some example questions. So I want you to take out your, we might look at some in a minute, but I want you to take out this worksheet packet. Now, we're not going to do even close to as many problems as are in here, but I do want you to know how to read these angle measurements. Okay, so let's look at maybe this page. I think it's like the third page, so number 1. So first we could use our protractor to kind of measure. Now BCA, let's color in which angle they're asking us about. BCA is referring to this angle. Okay, so we could use our protractor, okay? So that's why I had you practice with that, but if you use your protractor, angle BCA comes out to be about 68 degrees. Okay. And then if you also use your protractor, angle B comes out to be about 67 degrees. So we can go ahead and figure out that angle A is 46 because they have to add up to 180, and actually that would be like, let's change this to 45 degrees. Okay, so then notice that angle B plus angle A would be, angle A plus angle B would be 112. So I'm just kind of figuring in. Now notice, by the way, we call this angle A. We don't have to call it CAB or BAC because this is the only angle A. Notice here, you can't call this angle C because it could be here or this exterior one, so you don't want to be too confusing. So then finally, the measure of angle ACD, now you could measure this, right? But notice that should be the same as what A and B together were. So I'm going to say this is 112 degrees. So there's all kinds of activities in here that you can practice, and I would really suggest that you do that, okay? We're not going to go through these all together, but there's some activities that you could either save for your classroom someday if you thought you might be teaching this. But really, I just kind of wanted to give you some materials that you could use later. Okay. All right, but let's do some that maybe ask us to do a little bit of algebra. Okay, so let's look at a problem that looks like this. So let's say we have a triangle where we have a line being extended out a little bit, and then let's say that I tell you that this is 40, this is 2x, and this is 3x. It's probably a good idea when you draw pictures for your students that you let them know that, hey, these aren't always to scale. That's good for preparing them for testing, okay? But also good if you're not that good of an artist like me. Like, that probably is not really a 40-degree angle is what I'm trying to say. It's much more narrow than that, but we're not going to worry too much about that, okay? So I do this a lot when I make drawings. I just say pictures not to scale. And that tells, you know, my student, hey, I can't make assumptions based on how she drew this picture, and also it kind of, you know, alleviates me from having to be the best artist in the world when I'm clearly not. Okay, so notice this is an exterior angle, right? And these are two angles that are not next to it, right? Non-adjacent. So I can say that 2x plus 40 has to be 3x. Okay, and then notice there's not too much algebra I really have to do here, right? I could subtract 2x from both sides, so I end up getting x is 40. So if x is 40, then notice if I was asked to find these measurements, now I could do that, right? So this is going to be 80 degrees, and this down here is going to be 120 degrees. Okay, notice if you plug 3 times 40 is 120, right? Okay, so let's do one more. And then honestly, I think you could do your homework from that. Okay, so we're going to be on geometry topics for a while, so you definitely want to stay up with all the things that I'm going over in the video lecture. All right, so let's look at another one. So let's draw the triangle first, because last time I didn't necessarily do that. It kind of confused what we were doing a little bit. So let's call this one X, this angle X. We'll call this one X plus 20. And then let's extend this line out a little bit, and we're going to call this one 120. Okay, so let's go with what I know based on the exterior angle rule. I know that 120 is supposed to equal the two interior angles being added up together. So this is going to be 2x plus 20 if I add like terms, correct? So now I'm just going to show some work, right? If I subtract 20 from both sides, then I get 2x. And then last but not least, divide by 2. So notice x is 50. So I probably should have included some instructions here, but let's just say I said to find x. Well, if that's all I said, then we did that, right? But notice, what if I would have asked you to also tell me what the angle measures are? Then you would have come in here and actually plugged it in. So this angle, not to scale for sure, right? But that would be 50, and this one would be 70. Okay, so again, we can say picture, not to scale. All right, so I only did 2 examples of those, but I really think you practicing on your own is kind of where you need to spend your time this week. So the homework is really over just this exterior angle thing. Make sure on the homework that you're reading it carefully. Sometimes it asks for x, and sometimes it asks for a specific angle measure. And to get full credit, you'll need to make sure that you're answering the question that was asked of you. Okay.